Our sun, a celestial giant, dominates our solar system. It is a swirling mass of plasma, a place of unimaginable power. Temperatures at its core reach millions of degrees. Nuclear fusion, the sun's lifeblood, churns within. This process releases a torrent of energy, radiating outwards. This energy sustains life on Earth, yet it also holds the potential for incredible destruction. The sun's surface, though cooler than its core, still simmers at thousands of degrees. Imagine a sea of fire, constantly churning and erupting. This is the face the sun presents to the cosmos. From this surface it unleashes a barrage of radiation, including intense X-rays and gamma rays. These invisible forces travel at the speed of light, carrying enough energy to strip atoms bare. Now imagine yourself hurtling toward this inferno. What would you experience in the face of such overwhelming power? How would the human body, so fragile in comparison, withstand even a moment's exposure? To answer this, we must first grasp the incredibly short time frame we're considering, a femtosecond. Time, as we perceive it, flows in a continuous stream, but imagine slicing that stream into unimaginably thin segments. These segments, far shorter than the blink of an eye, are the realm of the femtosecond. A femtosecond is a million billionth of a second. It's the time scale of atomic and molecular interactions, a realm where our everyday intuition struggles to keep up. To put this into perspective, light, the fastest thing in the universe, travels approximately 0.3 micrometers in 1 femtosecond. That's less than the width of a human hair. In this fleeting moment, the universe seems to hold its breath. Chemical reactions halt mid-process. Even the vibrations of atoms seem to freeze. It is within this impossibly brief window of time, a mere flicker in the grand scheme of the cosmos, that we will explore the consequences of a fall onto the sun. Our journey will take us beyond the familiar to the very edge of understanding, where time itself seems to warp and bend. Before we embark on our hypothetical journey, let's be clear about the parameters. We are not talking about a leisurely descent towards the sun, nor a fiery plunge through its atmosphere. Our scenario is far more instantaneous. Imagine being teleported for just 1 femtosecond to a point just above the sun's surface. This distinction is crucial because it eliminates the prolonged agony of a traditional fall. There's no time for the searing heat to incinerate your flesh, no opportunity for gravity to crush you under its immense weight. In this thought experiment, you are exposed to the sun's fury for the briefest of moments, a fleeting interaction with an inferno. Think of it as a cosmic snapshot, a glimpse into a realm of unimaginable energy and chaos. What would you perceive in that instant? What changes would your body undergo? To answer these questions, we must delve into the specifics of the sun's most potent weapons, radiation and heat. The sun bombards our planet with a constant stream of radiation. It's this radiation that warms our world, drives our weather, and enables life to flourish. However, this life-giving force also has a darker side. At close range, the sun's radiation becomes a torrent of high-energy particles capable of wreaking havoc on living tissue. In our femtosecond encounter, we would be subjected to this intense radiation, but with a crucial caveat: time. While powerful, radiation takes time to interact with matter. In a femtosecond, only a tiny fraction of the sun's radiative energy would have the opportunity to interact with your body. Imagine a hailstorm of photons, each carrying a minuscule packet of energy. Some would pass right through you, unnoticed. Others would collide with atoms in your body, potentially dislodging electrons or breaking chemical bonds. However, the sheer brevity of the exposure means that the overall damage would be minimal. Section 5. A moment too brief heat transfer in a femtosecond. Heat, the transfer of thermal energy, is another major concern when it comes to solar exposure. We've all felt the warmth of the sun on our skin, but imagine that warmth amplified a millionfold. The sun's surface is a searing inferno, hot enough to vaporize most materials instantly upon contact. However, even heat transfer requires time. Heat flows from hotter objects to cooler ones, and the rate of this flow depends on various factors, including the temperature difference and the materials involved. In our femtosecond scenario, there simply isn't enough time for significant heat transfer to occur. Think of it like dipping your finger into a hot cup of coffee. If you do it quickly, you barely feel the heat. Similarly, in the fleeting instant you're exposed to the sun, The surface of your body might experience a minuscule temperature increase, but the heat wouldn't have time to penetrate any deeper. Section 6. The gentle giant's tug. Gravity's subtle influence. The sun's gravity is another force to consider. It's what holds our solar system together, keeping planets in their orbits and dictating their movements. The sun's gravitational pull is immense, about 28 times stronger than Earth's. However, like radiation and heat, gravity's effects are also bound by time. In a femtosecond, the sun's gravity wouldn't have enough time to pull you towards its center with any significant force. You wouldn't feel a sudden, crushing weight, nor would you be pulled apart by tidal forces. It's important to remember that gravity is a relatively weak force compared to the other fundamental forces of nature. It's only over vast distances and timescales that its effects become truly apparent. In our blink and you'll miss it scenario, gravity remains a silent giant, its power held in check by the constraints of time. Section 7. A flash in the void, the illusion of sight. Our senses are our windows to the world. What would they reveal during a brief encounter with the sun? Let's focus on sight, the sense most associated with astronomical observation. Would you witness the sun's fiery spectacle in all its glory? The answer is more nuanced than yes or no. Light from the sun floods your eyes, but processing takes longer than a femtosecond. Signals from your retinas to your visual cortex operate much slower. You wouldn't see the sun traditionally. Instead, you'd experience a brief, intense flash as photons bombard your retinas. This flash would persist for a fraction of a second, long after your visit to the sun. Our perception of reality is often a delayed and filtered interpretation of actual events. Section 8. The price of time comparing exposures. To truly grasp the significance of a femtosecond on the sun, it's helpful to compare it to longer exposures. What would be the consequences of spending a millisecond, a second, or even a minute on the sun's surface? As the exposure time increases, the cumulative effects of radiation, heat, and gravity become increasingly severe. A millisecond might be enough to cause significant burns and radiation damage. A second would likely be fatal, with the body rapidly heating up and beginning to vaporize. A minute-long exposure? That's beyond the realm of survivability. The human body would be utterly incinerated, reduced to its constituent atoms, lost forever in the sun's fiery embrace. It's a grim reminder of the incredible power of our star and the importance of keeping a safe distance. Section 9. The myth of instantaneous vaporization debunked. Popular science fiction often depicts objects being instantly vaporized upon contact with the sun. While dramatic, this scenario is not entirely accurate. While the sun is incredibly hot, the process of vaporization, the transition from a liquid to a gaseous state, still requires time. Think of it like boiling water. You can't instantly transform a pot of water into steam, no matter how high you crank up the heat. It takes time for the water molecules to absorb enough energy to overcome their intermolecular bonds and escape into the air as vapor. Similarly, vaporizing a human body on the sun, while undoubtedly a swift and unpleasant process, would still take a finite amount of time, likely on the order of seconds or minutes, depending on the size and composition of the body. The idea of instantaneous vaporization, while a visually striking concept, is ultimately a scientific inaccuracy. Section 10. Embracing the cosmos curiosity ignites understanding. Our exploration of a femtosecond on the sun has taken us to the limits of time and space, encountering unimaginable energies. We've explored human perception and debunked misconceptions, engaging in the pursuit of knowledge fueled by curiosity to understand the universe. This hypothetical scenario reminds us of the incredible forces in our cosmos. The sun, our life-giving star, is a source of wonder. Next time you feel the sun's warmth, appreciate the physics and chemistry that make life possible. Never stop asking questions, for curiosity unravels the mysteries of the cosmos. Subscribe for more explorations of the universe's intriguing questions. Let us know in the comments below.